So how many terms of the AP 6 whole number 1 over 4 plus 8 whole number 3 over 4 plus 11 whole number 1 over 4 and so on must be added together to obtain the sum of 240. So we don't know how long we are going to add this sequence together to get 240. So if I'm to solve this now, I'm going to use the formula for calculating the sum of terms of arithmetic progression. So solution. So I'm going to say Sn equal to n over 2 into bracket 2a plus n minus 1 times d. Now, what we have to find here is n. Then we are already giving Sn to be 240. That's the sum must be added together to obtain the sum of 240. So in this case, Sn is 240. We have the first term, A is clear. That is a 6 whole number 1 over 4. Then the common difference, we get that now. Okay, let me just say the second term minus the first term, 8 whole number 3 over 4 minus 6 whole number 1 over 4. If I do this subtraction, okay, let me just do it here. So we have 4 times 8, that's 32. 32 plus 3, that's 35. 35 over 4 minus 4 times 6 is 24. 24 plus 1, that's 25 over 4. Now looking for it, I have this as 4. 4 divided by 4 is 1. 1 times 35 is 35. We have minus 4 divided by 4 is 1. 1 times 25 is 25. To now have this as 35 minus 25, that's 10 over 4. So 2 here 5, 2 here 2. So we have 2 whole number 1 over 2 as the common difference, or 5 over 2. So having done that, then I can now substitute what I have now to get my n. That's what we have to find. So if I substitute now, I have Sn. Sn is 240. So I have 240 equal to n over 2, okay, into bracket 2 times a. My a in this case is 6 whole number 1 over 4, which can be written as 25 over 4. So let me just write this as times 25 over 4, okay, plus n minus 1 times d. So the difference is a 5 over 2. Okay, so I'm going to do this operation now to get my n. So if I'm doing this now, I'll just say this 240 equal to, we have n over 2. Then the one in the back, I can say 2 here 1, 2 here 2. We have 25 over 2 plus, if I open up this one now, they can use this 5 over 2 to multiply n. Also use 5 over 2 to multiply 1. I have that as 5 over 2n. You have minus 5 over 2 times 1, 5 over 2. Okay, now from here now, we have 240 equal to n over 2 into bracket. I can simplify what we have here in this bracket. So using 2 as LCM, we can have this as 25 plus 5n minus 5 minus 5. So we have 240 equal to n over 2 into bracket. 25 minus 5 is 20. So we have 20 plus 5n upon 2. Okay, so when we have something like this, we multiply. I have 240 equal to n into bracket 20 plus 5n all over, we have 2 times 2, that's 4. So when I cross multiply here, I have 240 times 4 equal to 20n plus 5n squared. So 240 times 4, let me do that here. 240 times 4 is 0, this is 16. So we have 960, which one is 16. So we have 960. So this will give me 960 equal to 20n plus 5n squared. So I can divide through by 5 to reduce the coefficients here. So let me just divide through by 5, divide by 5, divide by 5, divide by 5. So this cancels this 5 here and 5 here, 4. 5 here, 1. 5 in 9 is 1, remainder 4. Okay, 5 in 46, that's 9, remainder 1. 5 in 10 is 2. So you can write this as 192 equal to 4n plus n squared. Okay, so I can write this as n squared plus 4n. If I go this way, it becomes minus 192 equal to 0. This one forms a quadratic equation. I'm going to solve it using any of the method. So I decide to use factorization method. So if I'm to use factorization method for this work now, then I'm going to look for 2 terms. And when I multiply together, we give minus 192 n squared, but the addition will give plus 4n. I'm going to look for the factors of 192. So factors of 192, I can make use of 2. So 192 divided by 2, this will give me 996. So I can still make use of 4. I think 4 will do. Let me try that. 4. So we have 190. We have 96 on here as one factor. If I divide 192, by 4, okay, I have this as 19 divided by 4 will give me 4. Remainder 3. Okay, remainder 3. This is 8. So we have 4. We have 48. Okay, so let's try 24. Okay, 24, 19, 24 times 6, 7, 8. Let's see, 8. 4 times 8 here. 8 times 4 is 38, 82. So we have 2. 60%. So 24 times 8, 8 and 24. What of 12? Let's see 12. 192 times divided by 12. 192 divided by 12. So we have this as 1. Remainder 7. So we have 5. 15 and 12. 15 and 12. So we have 1 here. 1. Okay, this 1, 12. Then we have remainder 7. 72 and 12. That's 16, sorry. So we have 16, we have 12, we have 16. So I've gotten that I have 16 and 12, 16 and 12, 16 and 12 here. Now I have 16 and 12. So you realize that 16 times 12, let me just try it here. 16 times 12. Okay, 2 times 6 is 12. Okay, so we have 2, and then 1. 2 times 1 is 2 plus 1, that's 3. 1 times 6 is 6. 1 times 1 is 1. So we have 192. So the product of 16 and 12 will give 192. But there's need for me to introduce a sign here, negative and positive. But this should be minus 192 n squared. So you realize that it's only when I have plus 16n and minus 12n that I have this to be plus 4n. And when I multiply these two, I have minus 192 n squared. So I'll just substitute here. Instead of writing this plus 4n, I'll change it to this one. So I have n squared plus 16n minus 12n minus 192 equal to 0. I'm using factorization method. So this and this are okay. We factorize, we have n into bracket n plus 16 minus 12 into bracket n plus 16 equal to 0. So n minus 12 equal to 0, or n plus 16 equal to 0. Here we have n to be equal to 0 plus 12, or n equal to 0 minus 16. So n equal to 12 or minus 16. But okay, let me conclude here. N that is equal to minus 16 is not valid. Because we're talking about, the question is how many. You can't say how many times, you can't say minus 16 times. So therefore it is the positive that gives the answer. So n equals to 12 times. Okay, so it equals to 12 times. Alright, I'll continue from the next video. I'll answer the other question. Find the last term of the AP.